All right. So today what we're doing is just a reminder of something that you've done a bit of before, and that's quadratic equations. So general form of a quadratic equation is this one here, ax squared plus bx plus c, where of course a, b and c are real numbers. All right. So they're the coefficients, and so then we solve these equations. So there's a few different methods that we can use. So factorising would be one way, factorise then the null factor law. The second one, completing the square, again completing the square to then factorise to then use the null factor law. Or thirdly, the quadratic formula, which is this one here, negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now as part of this particular formula, the quadratic formula, the part that's underneath the square root, so this bit here, just that bit is what's called the discriminant. And we use a little triangle, and it's b squared minus 4ac. And so what this does is indicates the number of solutions that there is to the equation. All right. And so if there's two solutions, then this number under here, the discriminant, would be greater than 0. All right, and you can square root that one solution when it's equal to 0, because then the square root of 0 is 0, and then you're adding and subtracting 0, which leaves you with the same thing. And then the third option of this here is about when it's less than 0, then you have no real solutions. So you're trying to square root a negative number. And in the real number field, you can't do that. You can do that with a thing called complex numbers that we will get to later. But for the moment, no real solutions, and the word real is there because no real numbers. All right, so, if we were, for example, looking at a graph, to graph these things, and we were making it equal to 0 to find the x-intercepts, then if we've got two solutions, like the first one, we've got two x-intercepts. If we've got one solution like the second one, then we've got our turning points bang on the axis. And then no real solutions, it doesn't intersect at all. Right, so that's just one example of solving that equation. If we're looking at a quadratic graph, however, we may have quadratic equations in other situations. All right, so that's it in a nutshell. Done a little bit of the factorising and completing square before. You may have done also again a little bit of the quadratic formula. So we'll look at more of that, and you'll look at more of the quadratic formula and the discriminant in methods. All right, so here's an example, and this example here is for us to solve 2x squared plus 5x equaling 12. So first of all, we need it to equal 0, so we need to take 12 from both sides. So we've got 2x squared plus 5x take 12 is equal to 0. And we then need to factorise that in some way or other. All right, so I'm going to do this kind of by inspection, I guess. So to get 2x squared, the only way you can get that is 2x times 2x. The minus 12, so minus 12, so minus 4 and 3, or 3 and minus 4, there'd be our options. So let's try the minus 4 and 3, then we'd go 2x times 3 is 6x, minus 4 times x minus 4x, which is 2x, so that's not enough, so that one's no good. Alright, so the other option, and there's other things that we could use, but I'm just going to try these ones first of all. And if the minus 4 and the 3 don't work, then we'll move on to something else. So let's say plus 3. Whoa. And maybe that's a bit not very nice. So plus 3 and minus 4. So 2x minus 8x plus 3x. That doesn't work either because that's minus 5x, but it's close though. It's minus and we want plus. So again, by inspection, then I'm going, all right, how about we go the other way around, and instead of the minus there, we have, get rid of that so I've got some workspace. If we get rid of that, we put the minus in front of the 3. All right, so if I go minus 3 and plus 4, all right, just so I'm trying this second one first. 2 4s are 8. And minus 3 equals x equals 5. So that's what we want. Null factor law then says 2x minus 3 is 0, or x plus 4 equals 0. So add 3, divide by 2. X is 3 over 2. Take 4, x is minus 4. So there are our solutions. So inspection, that's got a bit of fluffing around, so you can use other methods if you like to do it. So like the trick method or the like to help you. All right, so let's have a look at the next one. So 3x squared plus 4x minus 2. All right, so this one's not going to be easily factorised. So if I'm going to try and get a binomial factors like that, I'm actually not going to find them easily at all with these. They're not going to be whole numbers. So if it's not easily factorised, we want to go to the quadratic formula. All right, so quadratic formula, remember, is the x value, and that x equals negative b plus or minus the square root of b squared minus 4ac, all on 2a. So b is 4, negative 4 plus or minus the square root 4 squared minus 4 times a, which is 3, times c, which is minus 2, all over 2 times 3. And say minus 4 plus or minus the square root of 16 plus 3 4s are 12 times 2 is 24 over 6. And oops, I don't want to go down there just yet. So then that equals negative 4 plus or minus 16 plus 24 is 40, I believe, on 6. All right, go up over here now. Didn't leave myself enough room. Minus 4 plus or minus square root. All right, so 4 times 10, so we're going to simplify that third to 2 root 10 over 6. Now with this, you'll notice 2 goes into both of those up the top and also into the bottom. What you need to do first before you cancel is you need to take the 2 out as your common factor. So -2 plus or minus root 10 on 6. Now we can cancel. Alright, so you need to take that out, so you've got times here before you can cancel, whereas at the moment in between there, plus and a minus. Alright, so once we've got that then, we've got -2 plus or minus root 10 over 3. Alright. Alright, next example. Consider the quadratic equation x squared minus 4x equals t. Make x the subject and give the values of t where a real solution can be found. So we've got the x squared minus 4x equals t, and we want to make the x the subject. So whenever it says make x the subject or make anything the subject, we want to get a sum or equation which has got expression which has got that x equals in this case. So what we've got here is we've got x appearing in 2 places. We need it in one place. So a technique that we can use here with this one is I can say, okay, what about if I make a perfect square out of the x squared minus 4x? Well, if I do that, what we know about completing the square, we halve this number, so -2, multiply by itself, plus 4, but don't forget we've got a -4 because this +4 has appeared out of us creating that perfect square, and that equals 2. Then we can add 4 to both sides here. Equals t plus 4. Now we can get rid of the squared sign, so by square rooting. And don't forget, when we square root, it's plus or minus the square root of t plus 4. And then add 2 to both sides, so x would be 2 plus or minus the square root of t plus 4. Then it says here, so that's the first part, made the subject. Then it says real solution. So real solutions, what's going to determine that is the square root, what's under here. Because for real solutions, we have to be able to square root that and get a real number. So real solution, when t plus 4 is greater than or equal to 0. 0 is okay because square root of 0 is 0. Take 4 from both sides, t's got to be greater than or equal to -4. Alright, so there's that. Alright, next one. For this expression, find the discriminant, solve the equation here in terms of p, and show there are 2 solutions for all values of p. Alright, that's interesting. Okay, so first of all, part A says find a discriminant. Remember, the discriminant is b squared minus 4ac. And in this case, b is p, so it's p squared minus 4 times 1 times -25 on 4. P squared, a negative here and a negative here is a positive. 4's cancel, leaving me with 25. There we go. B, solve that in terms of P. Well, again, this is where we use the quadratic formula. So x equals -b, I'll write it over here, plus or minus square root of b squared minus 4ac all over 2a. All right, so negative b is p, remember p, so negative p plus or minus square root of, now the b squared minus 4ac bit, well that's what we worked out here, and so that's p squared plus 25 all over 2a, and a is 1, so that's all over 2. So there's our answer. No more to do. So it says solve that in terms of p. Well, this is in terms of p, so whenever it means in terms of, means that you're going to have that in the answer. So I've got p in the answer. All right. So then show there are two solutions for all values of p. So remember, it's the discriminant that we're looking at. All right. So C, and the discriminant is equal to p squared plus 25. So when we look at that, and we have a look at that, so no matter what p is, when you square p, you get a positive number. All right. Because if p is negative, negative times a negative is a positive. If p was positive, positive times a positive is positive. Then what we're doing is we're taking that negative number, the p squared, and we're adding 25. So we've got a positive number plus 25. Well, again, that's going to be a little bit bigger, 25 bigger in fact, and that's a positive number as well. So from that, the discriminant is always greater than 0. All right, so what that then for means is there's two solutions. Okay, it's not asking us to find out what they are, it's just asking us to show that there are two. And you think about it, smallest value in fact is when p equals 0, and when p equals 0, it's 25, so that's a positive number. If p is negative 1 squared is 1, plus the 25 is 26. All right, so if you're a little bit confused about that or need more clarification, make sure you give me a yell, because that's kind of a little bit of a different kind of thinking process than you may have been used to, as is this one up here. Different kind of thinking process. All right, let's go to the last example for this section. Solve the equation x minus 4 root x minus 12 equals 0. All right, so this is something that's got a different technique and a new bit of thinking as well. Issue we've got here is we've got an x and we've got a root x. And so the root x is difficult for us to deal with. It's got 3 terms, 1, 2, 3 terms. So it looks a bit like a trinomial, but it's not a quadratic because it hasn't got a square. So what you can do, however, is you can do this. You can make a substitution. You can say, okay, so what I'm going to do is I'm going to help me solve, I'm going to let x equal a squared. And a is greater than or equal to 0. All right? That's because we've got this root here. So if I do that, if x is a squared, then I'm replacing this x here by a squared, and I've got a squared minus 4 root. Replace that x by a squared minus 12 equals 0. So a squared minus, now these two, squaring and square rooting is opposites of each other. Factorise two numbers, multiply to 12 and add to give -4 would be -6 and +2, I reckon. So null factor law says that a minus 6 is 0, or a plus 2 equals 0. All right. So then a is equal to 6, or a is equal to -2. Now from up here, what was said that we want a to be greater than or equal to 0. All right, so if we want a is greater than or equal to 0, then that particular value of a is not possible. So this is the value of a. Now remember, we introduced a to help us solve the problem. And what we know is that we know that x is equal to a squared. So what that means is that x is equal to 6 squared, which is 36. So that sum there, this one here, will be equal to 0 when x is equal to 36. And again, as I said, that's another different kind of thinking in the way to solve that. So if you need some more clarification, give me a yell and I'll give you help. All right, so that's it for that particular section. So as always, have fun, and if you need assistance, make sure you ask for it.